Okay, class, today we're going to be doing combined transformation, which means more than one type of transformation at a time. So I want you to consider the parent functions below. The first one I have an absolute value function, and the second one I have a quadratic. So I want you to use the tables to sketch their graph. Now I'm going to do a rough estimate on what that is, but I expect you to be more exact. So I know that this is a absolute value, so I know that it's going to look remotely like that, and that it's going to go on off into infinity. Now, for my quadratic, I know that it's going to pretty much look like this. Now, we know how to transform the parent functions, but what happens when two or more transformations are done to that parent function? Does the order in which the transformation are done matter? And that's what we're going to look at. So the two parent functions are shown below with several of their family members. Remember we talked about family members are things that have the same trait. I know that this is related to this because they both have the absolute value sign. I know that this one is related to this one because they both have an x squared. So make sure you understand what is meant by family members. Okay, so now on the pages that are following, you will be asked to predict how you think the graph of each transformation function will differ from the graph of its parent function. You're also going to be asked to graph each transformation function along with its parent function. And remember I told you it's a good habit to either use color markers. You know, if I want to show that I have two different colors or two different graphs, I may use color markers. Okay, it's also good to, bold one if you want to. So then we're going to compare the observations for the transformations, and then we're going to record any observations that appear to be both from families of the functions. So let's go to the next page. So now we have combined transformations, and I'm going to have to adjust my paper just a bit. So bear with me 1 second. Okay, I know that's not ideal. I got it kind of squished in a little bit, but you can see really what you need to. So let's look at the first one. So I know that for y equals the absolute value of x minus 3 and for y equals x minus 3 squared, I'm going to do a prediction. So I want you to predict on each one what you think will happen. So I think that there will be a shift of 3 units to the right in the graph. So then I'm going to actually graph the parent function, whether I do it by hand by plugging in my x values to determine my y values, or if I use the calculator. And then I'm going to look at my calculator to see what the actual effects were. So let's go ahead and pull up the calculator to do this one, even though I'm okay with you doing it by hand, and I actually prefer you doing it by hand. Okay, so I'm going to go to y equals. I'm going to clear that out, and I'm going to clear that out. And I'm going to go ahead and put the absolute value. Now, if you don't remember where the absolute value button is, you can always hit second catalog, and it's going to bring every program in that calculator up. And as you notice, ABS is first, which is absolute value. So then I'm going to put in x minus 3. And now, because it opened up that first parenthesis, it made that an absolute value. So I can just close it, and it'll make that an absolute value as well. Then I'm going to go down. And remember, I want to know how this differs from what? My parent function. So I'm going to go ahead and put my parent function here, which we talked about before as well. I'm going to hit second catalog. Second catalog. Absolute value. And I'm going to put the absolute value of x. And I'm going to go ahead and bold this because we talked before about wanting to differentiate between the two. So now I'm going to graph it. And remember, the bold one is my absolute value one. So I can see that it actually shifted 3 units to the right, which is exactly what I predicted. Well, now I'm going to go ahead and plug in the next one, which is open parentheses, x minus 3, close parentheses, square. And then I'm going to plug in the parent function, and who can tell me what the parent function is for that? That's correct. It's x squared. So now I'm going to hit graph, and remember the parent function is bolded. So that's what I result with, but that's what I started with. And then when I look at it, I can see that it shifted 3 units to the right. Yes. So then I'm going to go over here to my sheet, and I'm going to write down that the graph shifted 3 units to the right, just like we predicted. Make sure you see that. 3 units to the right. Now, you're going to do the same for the rest of the sheet. You're going to go ahead and predict what you think is going to happen. And then on the final page, we're going to have some more predictions. Let me scoot this in so you can see this as well. Just bear with me 1 second. Okay, that's much better. So we're going to have more predictions of different things that we're doing. And then you're going to, like I said, predict what's going to happen. Graph the parent function, or each one with the parent function, because it's giving you the parent function there. And then you're going to write down what actually happens. Any questions? You're right. They're going to have to wait till tomorrow. Have a good evening, and I hope you all did well on this activity. See you soon. Bye-bye.